Right, so you can see I've got the meter across the first cell. Right, this is negative, middle, positive. So we've got negative to the middle, and it's showing 3.6. Right, the voltage of the two cells is 7.6. So obviously one's at 3 volts ish, and the other one's at 3.6. So there is an imbalance there. Now the idea of a cell balancing circuit, and this is where the practice comes in, is or the one that I'm going to create, basically what it will do is it'll take the power from both of those, the total power, which currently is 7.6, right, as an input, and then use essentially a buck converter to create the voltage, okay, and then it will then put that voltage in there. So what it's essentially doing is not charging this. Essentially, what it's doing is it's removing power from this and transferring it from this by removing it from both, but then transferring it back to that. Let's just say the power pack draws, like, make it easy figures, right? Say it draws 1 amp at 7.6 volts, okay, and then obviously if it's an efficient buck converter, then that means that will have 2 amps going in there, won't it? At whatever voltage it is, 3 point whatever, you know. So, but because it's drawing 1 amp from here as well, it's actually only putting 1 amp in there. Yeah, because it's drawing 1 amp at these terminals, right, which is the whole circuit, and it's putting in at 2 amps, right? So it's subtracting 1 amp from the 2 amps it's putting in, which means there's 1 amp. But the whole circuit is drawing an amp from here as well. So what you're essentially doing is taking an amp from there and putting it in there, which then balances the cells. That would be the idea, the theory. And you can do the same this as well. Okay, you could be able to do the same with this, because what you do is you do it with an isolated buck converter, you see. Basically what they call a flyback converter, which is isolated, which means you can then connect it to whichever cells you want and it's not going to cause any problems with the grounding. So if you put it in there, you'd do the same thing. You'd be drawing an amp from here, yeah, and putting 2 amps into there. Yeah, but you're drawing an amp from there in order to put 2 amps in, so that means you'll have 1 amp going in there and it'll be drawing it from there. So the cell balancing in theory should work. The reality is buck converters are in the region of 80% efficient. So you won't be putting 2 amps in there, you'll be putting 1.8, right? So you'll be putting 0.8 in from there, you put 0.8 in there, and you'll be drawing an amp from this. You see, because you're losing the 20% in the conversion process. Okay, so you are actually losing 20% overall of the power, but you're not talking about charging it from flat to full, are you? You're only talking about topping it off. So the capacity of this one may say be, let's just say for instance this one's at say 60% and this one's at 80%, right? So what you're going to do is you're going to draw essentially 10% of the power. Just let me turn that off. Came on for no reason. You're drawing 10% of the power from there, right, in order to put it in there, but you lose 2%, you see. So you'll probably be drawing like 11% from there, and then topping that one up to get the both voltages, right? So that means overall you're losing about, I don't know, what is that, about 1 or 2% of the entire pack. But because this one has now got its voltage risen, then when they both go flat, because they both go flat together, when this one reaches flat, this one still has charge in it, which you can't use. So it's better to lose a bit and put that charge in, then balance them, so you can actually use the charge from the pack's purposes. Obviously you're wasting energy, but it means it's about range. It means it gives you more range, because you're then equalizing them, and then they both go flat and full together, you see. So you increase your range, you see, which is what it's all about. You know, the fact that one of the cells is degraded, I mean, essentially that should only happen like once, because say for instance you assemble the battery and they're all on higgledy-piggledy voltages, and the cell balancer goes through and basically equalizes them. Once it's equalized them, then it shouldn't be actually doing any work after that, so you're not going to lose any power. You're only losing the power during the actual rebalancing phase. Once the rebalancing's happened, right, then you shouldn't be losing any power, because the balancer won't be doing anything, yeah, other than monitoring. If you have a dud cell, then you're wasting power anyway, because that dud cell is wasting the power, you see. So you're losing it through that dud cell anyway. So it's not like you're actually wasting energy that wouldn't otherwise be wasted. So anyway, that's my take on it. What we got now? 3.65, and that's 7.6. Yeah, so we're going to leave that basically sat there. Eventually that'll get to 8 volts. And what I'm going to do is construct a monitor for these two cells, which then gives me a BMS to monitor them. It's obviously only a 3.1. And also I can construct a cell balancer. But I can construct, well, yes, I really should construct it from this battery, but initially I can just do it from another 8 volt power pack so that I've got the isolation. Yeah.